All right. So I think the goal of this track today is very simple. What does it mean for you? What does it mean for you? And my session, basically, I'm a part of this group called Zoho Labs, where we set the broader strategy, broader directions. We work on common problems across our teams. So there is a database research team, there is a hardware research team, and then there is an AI research team. So the first keynote is going to be talking a bit about technology and what does it mean for you. So I have this is going to be my agenda. Let's take a purely technological standpoint, and don't worry, I'm not going to hype it up. Again, stick to the basics. Where do we see this technology going, and what we are doing about it at Zoho at a very high level, followed by what does it mean for you, the customer. I'm sure there is a lot of fear of missing out on, am I the only one who is not getting the best value out of AI? All X threads that I read claim 30% improvement, 40% improvement, or sometimes even 10x improvement. But I am not seeing that in my business. How do I go about it? So that's how I'm going to end, followed by multiple sessions where we will have focus sessions on AI in customer experience, and AI in BI, AI in your internal collaboration and productivity, AI in finance. So we have, that will be more product focused, more specific examples and use cases from products that you love and use. My presentation is going to be highlighting the technology and seeing where it goes and seeing what we can do about it. So let's get into look back and see how this technology evolved. And the idea behind this is to cut out the hype. I mean, like Tony said yesterday, it's okay vendors hyping it up, but the media also has joined in hyping it up. The problem is the name of the technology itself, artificial intelligence. It's neither artificial nor intelligence. So where does this live? So you have had multiple innovation waves. Now, each of these waves are, they defined a whole lot of transition in the way we worked, in the way we lived, and companies that rode one wave successfully weren't around in the next wave, right? And AI innovation is currently in full swing. It needs the elasticity of the cloud and the connected data. The whole big data, small apps concept, right? Where you had multiple data points distributed across your systems. You've got cheaper sensors. You've got inexpensive and expansive cloud computing on offer. And then you've got revenue models that were built around data, especially in the consumer software. We don't pay for our search engines, we don't pay for our social networks, but instead we give back a lot of our personal data. And they are very successful trillion-dollar businesses. So the way we see this going in AI, and like any wave, technology gets incubated in the consumer side of things and then slowly moves into the business side of things. So now is the time for AI to make inroads into business. And of course, businesses cannot afford to subsidize their software with data. Right? Privacy is an important thing. My business's information is my sensitive information, and handing it over to a competitor would mean that they are going to milk it to their advantage. So several innovations within AI. Let's zoom into AI and see what started off. I mean, AI as a technology has been around since 1960s. There has been this AI summers and AI winters where overpromise, underdeliver, overpromise, underdeliver, overpromise, underdeliver. Even now, I think it's an overpromise, but it's not under-deliver. We having some sort of real value that we see. I mean, I find myself constantly using some or other LLM for my personal use, and even at work, I've started using these stuff regularly. So this is the best wave of AI that we have ever had. There is no under-delivery. There is some sort of meaningful, but it's still overhyped, I believe. So just looking at all these cloud-based enterprise software stuff, we started off in the 2000s with rule-based systems. I mean, we all know what this is, where you had to go manually write out the rules. You had to go say, if this person has not responded to my email in 3 days, then maybe send them a reminder. So rules, where you had to codify each of the rules. We have had a lot of such use cases across Zoho over the years, and this is what we call automation, right? Where a human writes the rules and you get an execution going on. And you need to have a smart human in the room to adjust these rules elastically so that it fits the current setup. For example, when I raised the travel request to travel from Chennai to Houston, I was asked a question, am I still vaccinated for COVID-19? Now that question was seriously relevant 3 years back, but today it doesn't make sense. So the person who is in charge of creating that rule, if not vaccinated for COVID-19, then do a different workflow. They just forgot about removing it. So these are the limitations of rule-based systems. And then come early 2010s, we started having classic machine learning. Again, this is just statistics, but the idea is you look back a bit of past data and then try to frame the rules on it. So what is the normal time that Ram Prakash usually logs into his system, usually logs into his Zoho portal? So, and you learn that by looking at past information, right? He always logs in between 9 a.m. and 10 a.m. All of a sudden, he is logging in at 2 p.m. This could be a potential anomaly. Or this is a Friday. Usually he works from home, but today I can see him logging in from a nefarious location. Now, maybe this is some place where you'll have to prompt a third factor or a second factor authentication. So you had this classic machine learning where you look at data, arrive at the pattern and introduce the rules. The human need not write the rules. So this is, in fact, this was one of the first use cases that we did in Zoho, where we started off with forecasting. Very simple, right? And this was the first launch. We did a soft launch where we had statistics-based forecasting thing and replaced it with a machine learning-based forecasting thing. So we know what is normal at a given point in time. We also did anomaly detection, again, where the idea was to write rules. Typically, employees log in between 9 and 5. But here is a night shift employee. He works with a different part of the world and he logs in at 3 p.m. So now, if you don't write that rule, you look back at the past data and learn, because a Monday morning 9 a.m. and a Saturday morning 3 a.m. will not work with the same rule. So these were some of our initial works, and then came deep learning. If you remember 2016, 17s, we had a flurry of Alexas of the world, Siris of the world, right? Smart speakers, which are smart microphones, but smartly named smart speakers. A lot of conversational assistants came into play, and that was the rise of technologies like deep learning. One limitation that the previous systems didn't have was that deep learning could go multimodal. Deep learning could work across images, deep learning could work across audio transcripts, deep learning could work across videos, but it still was not able to generate anything. You need to have a training data, and then you need to train your models to do it. So we started with expenses, receipt digitization, and the idea was we had to train the model with millions of receipts that we had to generate ourselves, so that the model learns how to do that. So today you just click a photo of a receipt, the expense system or any other extractor in Zoho automatically extracts all information. So this is when images started coming into the system. What was all the systems and rules in your product, in your business software, became images, and then came translation as well. So again, you are able to look through text. You don't have the translation of the exact text in your training data, but then the system is able to learn. So this was the era of deep learning. Then came transformers. Transformers are, they really transformed, I would say. What started off with neural networks, it became an evolution from deep learning to transformers. Again, transformers are still deep learning, but run at a massive scale. They are massively parallelized, heavy amount of data, heavy amount of infrastructure. You just pump in a lot of money and then you have transformers with you. So here is a good example. Here we're trying to do call transcription, and then you're able to ask questions on the call transcriptions in the system. So this is from our CRM system, where you can look at the key highlights, the names of the people, the emails that were spoken about. Right? So there is an outgoing call transcript that has been uploaded into your CRM, and then you get information on that. So you saw a lot of demos yesterday where Raju showcased how you can search through these transcripts and summarize, and then go back and to the exact timestamp of where, let's say you want to talk about when did the customer talk about the API limit exceeded bug, and it was in the 34th minute of your 1 hour call. Now that adds a lot of value. But even then, this is plain transcription. In the transformer era, there was not a lot of intelligence, which only came after generative AI came in. Then came generative AI, ChatGPT, Gemini, Anthropic, Cohere, DeepSeek, Quen, as we know. This really has changed the way. Uh, I mean, I am a bit too lazy to go look up Google now, search through a ton of links, and I'm sure all of us do that. Or uh, I have to write a super professional email, so I tap in the email assistant in Zia to give it the prompts and then make it professional. Or I'm sending a very light-hearted email to my team, so give it a prompt, and it's not like the computer understands all of these emotions, but the generative AI, the transformer, is able to mass produce it and make us feel like it has understood all these emotions. So this is an example from Zoho projects, again, where you have a business requirements document, so you upload that. You see, the computer is not just generating some essay or paragraph. It generates a whole project plan for you and then calls the right APIs in Zoho projects and then makes it actionable. You can also edit it at each point in your workflow, but this makes life easier, right? This also brings in a lot of context where you look at all your historical information. Okay, typically, this is how projects goes. Typically, this is the time taken for doing this step of your project. And typically, these are the experts that operate on this area. Now, there is a ton of information that is captured in your system. I'm telling you, it's not going to be perfect, but it's going to get 80% of your job to start off with. And here we have a prompt-based code generation. This is a screen grab from Zoho Canvas. My colleague Tejas will talk more about AI in developers shortly during the day. But here you're trying to create a React app where you look at the template, you look at the steps, and then it gives you the commands that it is executing. And you have a node and a React app in like a couple of minutes. Right? And we have the same capability. You get it, right? I mean, you give it a prompt, you're able to create a project, you're able to create an app, you're able to create a low-code app in Zoho Creator, you're able to create a workflow, you're able to create an agent, which my colleagues will talk about in the Agent Studio session, the last session of the day. Right? So this is where we are right now. There you go. You got the personal portfolio web page just by giving a couple of prompts. All right, then they want to edit it. They want to filter in the project section. Sorry, it is in Zoho Catalyst. Yeah. There will be a deep dive into this during the developer session in the same track, AI in development. It is a part of Zoho Catalyst. Yeah. It is our serverless infrastructure development platform. Yeah. You can. What is the name? It's Zia powered code generation. Yeah. And you can also do this in Creator as well. But it will be a Creator app. This can be a React app. All right. Yeah, this is from Zoho Analytics, our BI tool. Again, we will deep dive into this in the BI session during the course of the day. You have a lot of raw information, and then just like a human would do, here is a ton of raw information. What are the insights that could I get from? So get me all the insights. And the thing is, AI is getting better of all of these subjective things. If you were to look at the same raw data, you will infer a different inference. If I were to look at the same data, I will have a slightly different take on it. Now AI is able to do all of that. So then comes reasoning and agentic AI. let's talk more about it. What we are doing in that space, we have a lot of pre-built agents that go by the name Ask Zia, and then there is an agent studio where you can build your own agents by prompting. There is a full-blown session at 4 o'clock today about Agent Studio, so I leave it to them. But here they are creating a agent that can send an email where get records by ID and send email, and the workflow happens to go in automatically. So this is how we have seen AI evolve from rule-based systems to machine learning, where you learn from the past data, to deep learning, where things went multimodal but were not connected. I mean, you had audio transcripts, you had OCR, you had translation, but they were separate pieces. Then came transformers, where you could combine, where you could get a summary of audio clipping, where you could get a translated version of an audio clipping. So the multimodal really became multimodal when the AI system worked across things. Then came agentic AI and generative AI and all of that. So where do we see this going? This is the next part. This is going to be some technological aspect here. What is the best way to predict the future? I mean, it's a lot of madness, right? So I know, I mean, when I first started doing AI, this is very difficult because things change very rapidly. Overnight, there will be a change. I live in India, so overnight, there will be a new benchmark. There will be a new state-of-the-art SOTA, as we call it. So it's very difficult to follow or keep track of what is happening. So how do you do it? I mean, one way is to look back and study the changes. So let me give you a small example. Let's say I'm dropping this clicker, right? And the formula to calculate this is half gt square, where g is going to be your gravitational quotient, 9.8 ms. And the idea is there could be a lot of forces acting on this clicker. The clicker itself might try to stay afloat. There could be a wind shear that blows the clicker away. But I'm not factoring in all of that. I'm just looking at the dominant force, which is gravity, and what could be the dominant force in AI. So the number of dominant forces in dropping a pen is very minimal. Interestingly, even for AI is very minimal. Any guesses? What do you guys think would be the dominant force driving AI? But there is even more a stronger dominant signal that we see. One way is to anthropomorphize models. Remember, Siri could be your personal assistant. She can help you do tasks, anthropomorphizing things, right? Which is essentially treating these models as humans. Is that right? It serves as a shortcut for some time to start off with. Computers are generally very good at us, very good than us in certain things. I mean, for example, what were we doing in 19th November 2018? Unless and until something really good or really bad happened in our lives that day, we won't remember what we did in 19th November 2018. But a computer can pull out information from your database and say, hey, on 19th November 2018, these were the leads that came into your system, these were the emails that you sent, and so on. So computers are built differently. It helps us get a start on where this technology is going, but it stopped there. This seemed to be the dominant force. Roughly 10x more compute every 5 years for the same dollar. The amount of compute that we have is exploding. It's literally exploding. So this is the price performance of computation. There's a very strong signal, right? And this seemed to be the dominant signal. Computing seems to be exploding. Computing seems to be getting cheaper. I mean, all the sensors that we have, 15 years back, had you told me I would have a sensor in my wrist that tracks my sleep, that tracks my steps, that would be some hi-fi device. But today it has been commoditized so much. It's so easy to collect all information. And then cloud is also getting cheaper and cheaper as we speak. It's easy to do all the analysis on top of that. All right. So the scaling is going to dominate the AI research from now on. It's not going to stop here. It's going to, I mean, today we say that we have a GPU shortage, GPUs are expensive, but it's been normalized. It's been normalized so much that we have added so much of GPU infrastructure to your systems. And how has AI research over the years? If you think about it, more general methods with weaker assumptions. Let me break it down that for you in the coming slides. And to where it has come is add more data and increase the compute power. That seems to be the trend here. And models of 2000s were more complex than models of 2024. Anybody remember data scientists are going to be the highest paid people in the world? They should know, I mean, here is the data, here is the algorithm, what is the alpha parameter, what is the beta parameter, what is the smoothing parameter. Now with generative AI, all that is obsolete, right? You ask for anything, it could summarize. There is no need to train a model. You just give it some examples, some prompting, maybe some fine tuning in some serious cases. But as we speak, every month there is a new model that comes with a longer context window. There is a new model that comes where you don't have to fine tune it. I mean, there is a same model that could be a lawyer, that could be a doctor, that could be an insurance specialist. Why do you have to fine tune it? Right? So models are getting bigger and bigger and bigger. There is very little control on what goes into the model. And let us think about general intelligence for a moment. Think about it as artificial general intelligence, right? Or think about it as tactical intelligence, right? I would say general intelligence is tactical intelligence. Today, ChatGPT and all these LLM tools are not tactically intelligent. You have a ton of information, it can summarize that beautifully for you. If you think about it that way, it's even more simpler, right? It can aggregate information, it can explain like I'm 5, it can help me. I mean, I give 3 lines of prompt and generate a 30-line email. So my colleague receives it, they give that 30-line email to the same assistant and get it as 3 lines. Right? So this is how we're doing it, but there is still no tactical intelligence. And have you all noticed, whatever you don't know, you ask an LLM, it gives you a good answer. But whatever you are an expert at, you ask it to an LLM, it gives you a so-so answer, right? So they took me to the baseball game day before yesterday, and Astros had a really good game. But I'm a cricket person. I don't know anything about baseball. So I had learned, okay, I know cricket. I've been following cricket all my life, and I'm going to a baseball match. Can you help me understand with reference to cricket? It gave me a decent first thing. But the statistician I am in, I saw there were a bunch of a matrix of numbers with some funny abbreviations. And it never told me that. I mean, I had to ask each and everything. So it's still not tactical. It can help you move from a C player to a B player, but never to an A+ player. So that is where we're seeing it right now. So let's think about general intelligence. Now let's think about, and I had my wonderful colleagues tell me, oh, this is how the game goes. This is what the 7th inning stretches are. When could an AI assistant get to that place? Think of that as general intelligence. So we started off with structured approaches where you had to model everything. You had to build a model for customer churn. You had to build a model for employee churn. You had to build a model for email sentiment analysis. You had to build a different model for customer support sentiment analysis, for chat sentiment analysis, and so on. Then came semi-structured approaches, which initially don't perform, but eventually they do perform as we speak. Then came unstructured. Unstructured is where, okay, so this is how my day goes. Here are my call logs. Here are my CRM records. Here are my emails. Here is my HRMS, which has all the information of the colleagues that I work with. Somebody is in, somebody is out, somebody is remote in, somebody is meeting a customer. They have their calendar, their travel plans, and all of that. Can you say, hey, I have a customer in Colombia that might not be renewing this year? Who could be the best person to go out there? You don't have to ask this prompt. By looking at the call transcript of you with the customer in Colombia, can you find out who is somebody from your team traveling in Colombia so that they can go meet that customer in person? Now that would be general intelligence, and that's a lot of unstructured information, right? A lot of unstructured information in terms of call transcripts, in terms of documents, in terms of emails, in terms of click messages, and all of that. But unfortunately, this is where our compute is today. We saw that compute is exploding, but our compute here is right at the intersection, right here. So we are still have to take a semi-structured bet on our systems. So should we choose unstructured and give more freedom to the model? Go learn everything that you have to, and then be that tactical intelligent assistant to me? Not today. Not today. We see that compute is exploding, but with the compute and the limitations that we have today, today is not the right place to be there. So what is better in the long term almost looks necessarily worse now. Very unique to AI research, right? You know that compute is going to explode and we are moving towards more unstructured general intelligence. But today, it's not going to be so good. If you're going to take that approach, you're going to come back disappointed. So we need to give more freedom to the model. How do we attack this? We need to give more freedom to the model, but with the right privacy controls. right? My HR manager should not ask a question to the LLM and ask, hey, looking at click messages of all my employees, give me the top 3 people who will leave in the next month. It's criminal, right? So you need to have these boundaries in place. You need to make sure that the personal boundary, the organizational boundary is very well protected. So let's talk about less structure and more structure. Applies to organizations and their technology adoption. Enterprises operate with varying levels of structures. This also affects how LLMs can be deployed. So your more digitally mature department could be your finance department or could be your marketing department, compared to your services department, which might not be digitally mature. So there is varying levels of structure right within your organization, and this affects how LLMs can be deployed. Agents could be a good way to solve this problem. And okay, so now that we saw where the technology is going, some structured, some unstructured, the dominant force being the rise of more and more compute, what are we doing? What is Zoho doing? How do we help you write this? I mean, this is the pattern that we see in the market. And how do we help our customers? What are we trying to do about it is going to be my next part. You will see more and more deep dives into our products today in the BI track. So we are going to talk about infrastructures and models as the key differentiators. Let's zoom into infrastructure. Like a lot of other SaaS players, we are not a reseller of compute and AI, right? They were resellers of AWS and Azure. Today, companies are becoming resellers of OpenAI and Google Vertex and all of that. So AI vendors are going to eat into a bigger chunk of the profit of SaaS players. So they're going to pass it on to the customers. We've got 16 data centers across the globe. We're building more as we speak. And in fact, this itself was crazy. I mean, when I joined the company as a naive intern in 2011, why would you build your own data center? Why not run it on AWS or GCP? I mean, I didn't understand the intricacies of that when I joined in, but when I look back and connect the dots now, this is one serious advantage that we have. And the total cost, the TCO was like so low that we are able to offer more value to the customers. We are also strategically positioning network POPs to increase the throughput, because once these agents and digital employees get going, there is going to be a lot of east-west communication within the data center. North-south communication is when you make a request to our data center. East-west is when two systems in our data center talk to each other. So we have to make sure the overload of traffic that's going to hit our systems with all these automated workflows with agents, our data centers are still going to be scalable. And we are working closely with hardware vendors, not just as a consumer, but as a technology partner. Last year, we announced our partnership with NVIDIA. We're also, from an engineering perspective, working very closely with Intel and AMD Xilinx as well. Again, the idea is to make sure that we get the best in breed, we get it very early so that we are ahead of the curve. And we've been using GPUs not only for AI video workloads, we've been using GPUs to accelerate databases. So Zoho Analytics, if you're a Zoho Analytics customer, if you're a Zoho CRM customer, if you're a bigger enterprise customer with a lot of things, and your databases are accelerated by GPUs. In fact, we had a session at NVIDIA's GTC where we spoke about how do we uniquely use GPUs. I mean, everybody uses GPUs for AI, but we've been doing a lot of stuff on database acceleration so that your systems are scalable. And not just GPUs, for AI perspective, we are also investing in a lot of ASICs, a lot of application-specific chips like FPGAs. Some of these are already live in our data center. If you use Zoho Meeting, if you use video calls on Click, that probably goes through this VCK 5000 card from Xilinx. So the LLMs are more of a HPC game than a model training game. I mean, we've been training models since 2012. But what is different is it's going to be the amount of compute needed. How do you manage this infrastructure? How do you make sure that the data syncs across these GPUs? Okay, you've got the fancy H100 GPUs in your data center. How do you make sure these talk to each other at scale? In fact, the first time we did it, they were operating at 70% throughput. They could do 100%. And then we realized that the Ethernet switches that connect these GPUs weren't enough. So we had to go back to NVIDIA, get something called InfiniBand connectors so that these GPUs operate at scale. So a lot of high performance computing learnings than AI learnings after the LLMs have come for us. And yeah, it's enabling power and bandwidth for these servers to talk to each other at scale. In fact, when we started off, we just were able to plug one GPU into one complete rack. What could be 8 servers? We could just plug only one server because the GPU's power requirements were so high. So we had a lot of learnings in that aspect. And Interestingly, what started in Europe, what is your carbon footprint? What is your, how much percentage of, we see this in a lot of RFPs right now across the globe, not just in Europe. And I think that's a good thing. And we've been constantly measuring our global renewable energy output is still higher than the consumption from our data centers. Okay, that's about the infrastructure part that we have built. Again, the summary is we've been investing a ton into our own data centers, and I see that as a key differentiator, especially in this AI era where compute is a big cost for AI vendors. And then let's talk about models. So we have over 80 AI algorithms deployed. I mean, this is what we saw where from each generation, right, from rule-based systems to classical machine learning to deep learning, we have over 80 algorithms deployed right now. We are getting 20 billion plus API calls per month. This is 50% year-on-year growth when compared to in 2025 when compared to 2024. And that means AI is becoming more and more serious. In fact, I was talking to one of my colleagues yesterday. AI has moved from marketing to sales. Right, we increasingly see a lot of conversations about AI in our sales meetings, in our RFPs. Last couple of years, I mean, I would say 2023, it was just all about marketing, but not much of a real impact. And this is where we differentiate very well. We are right-sizing these models. For us, not everything is an LLM problem. Right? There are vendors that do that. And that means a ton of compute that is needed, a ton of data that is needed to keep these models afloat, to keep these use cases going. So the fact that we have stayed in the game longer, right from investing in classic machine learning to deep learning and all of that, helps us right-size models. I mean, you don't need a LLM to do anomaly detection for you. You don't need a LLM to do something like best time to call a customer, right? Look at the carbon footprint that we minimize. There is a model that only does best time to contact a customer. There are use cases where you need this emergent capabilities. That is when we go to the LLMs. So right-sizing the models really helps. It helps us rationalize compute and data. And the need for bespoke AI models, like I said, especially in our infrastructure, all of these LLMs are really good in human language, but they're really bad at machine language. So you've got pair programmers, but have you seen a pair debugger? Have you seen there is a network fault, there is an AI ops guy. Have you seen a pair debugger AI, a co-pilot to actually help them debug? We aren't seeing more of that because these LLMs aren't really good at machine language, right? But in the next 6 months, we will see a lot of that. We will see a lot of that. But today, the need for bespoke AI models to fit a particular use case is still there. So this is what we have done. All of these are available within the platform, available within Zoho's platform. All of these are available for the agents on Zoho's platform to consume so that they can mix mash information, run it through these algorithms and get you the results. So this is something that we have painstakingly built over the last 10, 11 years. And all that said, the platform becomes the enabler. Our search platform becomes our RAG database. So I want to emphasize this. So if you think about it, remember I told you an example. Can my HR manager go and ask, look at all employees, click information and find out who will leave in the next 30 days, right? But the very fact that we have built our AI engine on top of our search platform means these privacy boundaries come for it. I cannot search through your click record even though we are colleagues. I cannot search through your payroll information even though we are colleagues. I can only search through my team's performance appraisal information because only search through people who report into me. I cannot search through somebody else. So building on top of search has really given us an advantage in respect to privacy. And of course, we've been a very privacy-aware company. We don't use your data to train our models. All our models are trained on a baseline open source publicly available information, then deployed into your ecosystem. And the model evolves with your data. Your data is never used to offer inference to your competitor or to other customers of Zoho. Your data is your data and your models evolve over your data so that it can serve you better. There's also an individual boundary. There's an org boundary, there's an individual boundary. Let's say you are a customer who uses Zoho and you are an employee of that customer. Then there are certain models that are built into your infrastructure, that are built into your privacy boundary, your individual boundary. So that is where we are. So these models evolve over privacy-first underpinnings, inherently aware of individual and organizational boundaries. And with respect to LLMs, we are building on top of self-hosted Llama and Mistral models. Raju showcased about the AI bridge. We are making these LLMs very flexible. If you choose to opt for LLMs hosted in the Zoho's data infrastructure, then you have a choice between Llama and Mistral. You can also connect to other proprietary players. Let's say you have an enterprise OpenAI account. You can put in your key and Zoho talks to. So we understand that flexibility is the key. We've had some enterprise customers who bring their own LLM and plug it to the system. So it's very open, but we are experimenting in the 3 to 7 billion parameter space. Like I said, right sizing models help. For not everything, you would need a 70 billion model. There are use cases that can be solved with a 3 billion model. And work is accelerating on our own fundamental, foundational homegrown LLM. Again, you could ask me, it's the same thing as data centers, right? We could be crazy to invest in a data center. So we're also investing in our own foundational LLM. We're dogfooding models between 7 billion and 100 billion models, but we don't want to release it hastily because there's a lot of legal involved. There's a lot of guardrails that have to be installed. And you are in the media the next day if your LLM is going to make some racist remark, right? So we don't want that to happen. So that polishing the last part has been taking us a lot of time. So we're already dogfooding this within Zoho. For example, Connect has a summary feature. Zoho Corp, the customer of Zoho, uses our own LLM to do that, and it's working reasonably well. I think my colleagues would assure that. So public launch is expected in a few months. And why do we do all this? We have ridden all the waves. We have this gives us an edge in terms of long-term deep technical know-how. Like I said, the LLM capabilities that we learned, the HPC capabilities that came along with it. So a lot of customers have asked me, is there a need for another LLM today, right? Because you're spoiled for choice in the open source world. You can just, there are models that can do everything, but this is what our chief scientist is spending a lot of time on, building verifiable models. Again, doing the same with minimal energy, with minimal data. This gives us an advantage to that. So, all right. So now we spoke about everything. I'm going to talk about what should you be doing. It's a lot of fear of missing out. Not many companies are still able to extract value out of AI. How should you be going about it? So I think the first step is going to be streamlining your processes. How much of your process is actually digitally captured, right? How much of your process is still a part of it? Your CRM should not be an afterthought, right? If you ask your sales guy to write notes after a call, that's not going to be enough. But if you could get a transcript of the call and transcribe the notes, that's going to be something. It should not be, your data creation should not be an afterthought. It has to be automatically as a part of the system. Same with your meeting recordings. Now, we do a minutes of the meeting. Now, if you ask somebody, depending on how smart or how not smart the person is, the MOM could capture varying levels of interest. If you have a good person who could capture MOMs, that's great. But if you could automate that, which is not missing out the essential details, not missing out the mundane in the sea of information, transparency, but with right privacy controls, and all of this audits and all become super important, especially when you're doing agents. This is where things like Zoho Directory come in, where there is a permission structure. You can give permission to an agent to only access certain parts of your system, and it cannot give you a holistic thing. So this is where process streamlining is coming in. How much of your process is streamlined across your system, across your departments? Like I said, departments come with different levels of maturity. Your marketing department is more digitally mature than the facilities department. Now, how do you streamline process that cuts through it? How do you streamline an onboarding process where profile comes in via recruit, interview happens, then they get onboarded into Zoho people, then the sysadmin has to give them all the access, all the corporate devices that you have to give them, and let's say there's an exit process. Again, that cuts through multiple departments. So streamlining your process becomes important. Streamlining your data also becomes important. AI does not like data in silos. Systems evolve over time. The COVID-19 vaccination example that I talk about, the system has evolved. And this helps improve prediction and reduces false positives. So I'll tell you, even within us, a 100% digital company, a software company, we have some gaps, right? For instance, I'll tell you, I tried booking a travel request to come to Houston. My boss had to approve it. Then I had to go get an on-duty request. I had to go to Zoho people and apply it. The same boss had to approve it, right? So the process has to be streamlined. And when the data is streamlined, now expense knows which flights I'm taking. Now, let's say there's a flight delay and I'm not able to go to the office next day. Would it automatically add a next day on duty to your HRMS system? That's how we want it to be. That's where we are heading to. Of course, I mean, these are evolving. These features are coming. But the more and more we connect our processes and data, that makes you more AI ready. And invest in existing automation, right? Your existing automation becomes all the more important so that AI could come in and make an impact. If you have done no automation, no rule-based automation, and you expect a $20 LLM to come in and do the magic, then that might be a bit of an over-expectation. So it's important to streamline your processes, streamline your data, invest in existing rule-based automation so that your system becomes more AI mature. There's a lot of structured and unstructured data in the enterprise. Make sure, this was the middle part of the presentation, right, where we spoke about structure and unstructured information. So for instance, all the records that go into Zoho Analytics could be your structured information. All the records that go into Zia Hubs, which Raju was demonstrating yesterday, where you got a summary from all your customer conversations, where you got a summary from all the contracts that you saw. That's a lot of unstructured information, right? So have a base. Zoho Analytics could be a base for your structured information. Zia Hubs and your work drive can be your base for your unstructured information. When you put all these information into places that should be with the right privacy controls, that makes AI more effective in your system. It's about how much of data that it can see, how much of a access control that you give the agent or you give the LLM so that it can make sensitive decisions for you. So your digital maturity is the first step to AI maturity, right? You are it's no longer about, we've been doing this for decades, right? Digital transformation, where we were take something from pen and paper, move it to a digital system so that it becomes searchable, it becomes more compliant and all of that. Digital maturity is still the first step to AI maturity. Give the same AI stack to 3 different companies, they will have 3 very different ROIs from the same AI stack, right? That depends on the digital maturity of the ecosystem. Think about it. You have Waymos riding here in US. Take the same Waymo, bring it to India. I'm sure it won't run. I mean, it's the same AI, but it's about the maturity of the ecosystem. It's about how well marked the lanes are, how well disciplined the other riders are. So investing in digital maturity could be the first step to your AI maturity. So play your usual long game with AI. I mean, don't panic. There is no fear of missing out. Yes, it's a natural evolution of your digital transformation. We had a system of records. Now we are trying to garner intelligence out of the system of records. Don't panic. You're not missing out much. There's still a lot of future promise, but get your digital maturity straight so that you become AI ready. So yeah, for us, what we offer at Zoho, the long-term know-how, the right sizing of models, plus the platform, the powerful platform that captures the entire customer journey, that captures the entire employee journey, becomes more important. And our goal is to pass on value to you, our customers. So that's it from me. Thank you. Thank you very much.